Okay, so this is higher paper question 3. The diagram shows 3 reactions of potassium. So we have potassium in the middle. Reaction 1 is the reaction with chlorine, which produces a white powder. Reaction 2 is the reaction with water, which produces potassium hydroxide and gas C. And reaction 3 is with oxygen, which produces potassium oxide. The first question asks us to write a balanced symbol equation for reaction 1. So in reaction 1, we know that potassium is reacting. So if we just have a quick look at our periodic table, then we know that potassium is the letter K. So we can start off by writing a K and leave some space for any balancing numbers or other symbols we might need later. And then that reacts with chlorine, and the formula for chlorine were given in the question. Okay, and those are the only 2 reactants necessary in this reaction. And we need to now work out the formula of the white powder. Now, there is only one product here, okay? So we can be confident that product is going to be potassium chloride. So if we write down KCl to start with, then we need to double check that that's the right formula using the table of ions. So what we need to do is find potassium, which is here, and potassium is K+. And if we find chloride, because when it reacts it becomes chloride, and that's Cl-, and we can see that these 2 ions are oppositely charged and they cancel each other out. So the formula is simply KCl. There's no need for any balancing numbers for that one. But when we go back to our equation, we notice that it's not going to balance. So if we use the box method, then we can put a K there. We can put 2 Cl's together, and we can put a KCl. And we notice that we've got 1 K, 1 potassium, and 1 K. That's good start. We've got 2 Cl's. I know they're a bit A's, but they are Cl's, but only 1 on this side. So the only way to make this balance is to add in an additional KCl. But in doing so, we've managed to double the number of potassiums here, so we need to add another potassium over here. And once we've done that, we'll find there's 2 potassiums, 2 potassiums, 2 chlorines, 2 chlorines, but we do need to correct the balancing numbers up here. Okay, so there's 2 marks there. Generally speaking, 1 mark for the unknown formula and 1 mark for the balancing. Okay, the next part says, give the name of gas C formed in reaction 2. Okay, so when potassium reacts with water, then basically we need to remember that the products are a hydroxide solution and hydrogen. Gas C is hydrogen. Okay, we can probably work that out from the hydrogen present in the water. Okay, so it's hydrogen. And then describe the test for the gas C. Again, this is a knowledge question. You need to know this. So hydrogen, it pops a lighted splint. Okay, so the 2 marks there are for the lighted splint, some form of ignition, and the fact it makes a pop sound. Squeaky pop might actually be a little better. And then this question here, complete and balance the symbol equation for reaction 2. Okay, so this is the reaction of potassium with water. Okay, so in the description, it tells us that we're getting potassium hydroxide. We've previously identified that the other product rather, the gas C, is hydrogen. Okay, so we need to write down the formula for potassium hydroxide. So from the name, we can probably guess there's some potassium present. Hydroxide tells us that it's going to be hydrogen and oxygen. However, just to be awkward, we tend to write the oxygen first and then the hydrogen. And then hydrogen gas has a formula like many elemental gases. It is bimolecular, which means it's got 2 atoms in it, so it's H2. Now, we might want to check this to make sure we've got the right formula. Okay, so again, we can use our table of ions. We rediscover that potassium is K, as we've already seen, and that hydroxide is OH minus, okay, which makes life a lot easier because once again, this gives us the formula KOH. Those, the positive and the negative balance or cancel each other out. So it's a simple formula of KOH. So this formula here is correct. But we do need to balance it. Okay, so the best method for balancing this is to use the box method. So 2K would look like that. 2H2O would look like this. Okay, we know that this is KOH, so we need to write down KOH, and this is H2, so that's just 2 H's. So at the moment, we've got 2 potassiums, but only 1 potassium here. So to make that balance, we need to add in an additional KOH, because that's the only compound in which K appears on this side of the equation. And in fact, in doing that, we may find that life's just got a lot better because we've got 2 Ks, 2 Ks. We've got a total of 4 H's here. We've got 2 and 2 makes 4 there. We've got 2 oxygens and 2 oxygens. So the box method is balanced. We simply need to transfer that information into our final equation. Okay, so that is now complete. And then explain the colour seen when a few drops of universal indicator are added to the solution formed in reaction 2. Okay, now reaction 2 is potassium reacting with water to make potassium hydroxide solution. And what you need to recognise, potassium hydroxide, is that group 1 metal hydroxides, so potassium hydroxide, sodium hydroxide, lithium hydroxide, are all alkalis. You also need to remember that the colour that universal indicator goes in an alkali, and that's purple, or to push a blue. Okay, so the alkali potassium hydroxide turns UI, which is the abbreviation for universal indicator, purple, or you might get away with blue, but go with purple. Okay, so the fact that you recognise it's an alkali and the colour change would give you the 2 marks. Final part of question 3, that's C. Again, balancing equations. So if we use our box method to start with, but we will need to work out the formula for potassium oxide. So we've got some potassiums, we've got O2, and then we don't know what we're going to write here. Now, a little clue or a tip, if there's a box in front of an element in a GCSE chemistry paper, the likelihood is, well, it's not the likelihood, there will be a number going in there. If there's no box present, there's no number required. But we do need to identify what needs to go here before we can look at the box. So if we put back to the question, shouldn't come as a surprise to learn that we're looking for potassium oxide. Okay, so again, we use our table of ions. We find potassium. We know from previous times that potassium is K plus. However, oxide is O2 minus. So this time we need to consider that we'll need 2 potassiums, 2 pluses, to cancel out or balance the 2 minus. So that makes the formula K2O, because when we combine them into a formula, the numbers become subscript just after the element in question. So the formula for potassium oxide is K2O. So we can now put that back into our question here, which you can't see. There we go. So the K2O would look like KKO, and we're using our box method. We now need to have a look at this. So we've got 1 potassium there at the moment, although we know we're going to need more. We've got 2 oxygens, and we've got 2 potassiums and only 1 oxygen. Now, in this case, it might be better to balance the oxygens first. We know there's going to be no more oxygens because there's no box present. So we know we've got to have 2 oxygens on this side, and the only place that oxygens appear is as part of the K2O. So that must mean there's a whole extra K2O. So we've now got the oxygens balanced because there's 2 of them there and there's 2 of them there. We've now got 4 potassiums altogether. Okay. So we will need 4 there. And we'll need a 2 here. Okay, so that we've got the balances basically. Okay, so that the 2 represents the 2 boxes, the 2 box diagrams. Okay, calculate the relative formula mass of potassium oxide. Okay, now we've already established that potassium oxide is K2O. Oops, K2O. So what we need to do is to take the mass of 1 potassium and multiply it by 2. So the MR of K2O equals 2 times 39, because there are 2 potassiums and our potassium weighs 39, plus 16. There's only 1 oxygen. Okay, so 2 times 39 is 78, plus the 16 is 88, 94. Okay, so 94, and as it's a formula mass, not a molar mass, we don't need the units. Okay, so that's the then finally describe how reaction 3 is prevented from happening when storing potassium in the laboratory. Okay, and so potassium, this is a knowledge question really, it's you need to remember this, is stored in paraffin oil to prevent it reacting with moisture in the air, or with oxygen, actually with oxygen in the air. Okay, that's question 3.